Let us discuss about electric field due to a uniformly charged sphere. Uniformly charged sphere. Electric field suppose this is a charged sphere of radius capital R. Q is the amount of charge. Let Q the amount of charge capital R, the radius of the sphere. Then charge density, volume charge density rho is equal to Q by 4 by 3 pi R cube. Case 1, if the point is outside the sphere, if the point is outside the sphere, let us take a point, a distance r. Let us take a point, a distance r outside the sphere means small r is more than capital R. Now imagine a Gaussian surface at that distance. Take a small area delta S. Here, since charge is positive, electric field is along the radius vector, and for this point, area vector is also normal, that is parallel to the field. Let P be a point imagine a Gaussian surface which is spherical. For an elementary area delta S, electric flux phi is equal to E dot sigma E dot delta S. This is E into 4 pi r square. Since theta is 0, for any point area on this spherical surface, as electric field, E electric field vector and area vector are parallel. Enclosed area, enclosed charge is Q. So according to Gauss law, phi is equal to Q by epsilon 0. Or E into 4 pi r square is equal to Q by epsilon 0, or E is equal to Q by 4 pi epsilon 0 r square, and the field is along radius vector. That's why we can write in vector form H Q by 4 pi epsilon 0 r square r cap. Case 2, if the point is on the surface of the sphere, on the surface of the sphere, then small r is equal to capital R and E is equal to Q by 4 pi epsilon 0 capital R square r cap. Case 3, if the point is inside the sphere, let us take a point at distance small r, which is case 3. If the point is inside the sphere, that is r is less than radius of the sphere. Now imagine a Gaussian surface at distance r. Imagine a Gaussian surface at distance r. At this point, let delta S be a small area. For this, area vector and field vector again are parallel. Electric flux phi is equal to E dot delta S is equal to E into 4 pi r square. Enclosed charge Q dash is equal to rho into 4 by 3 pi small r cube. Again, rho is equal to total charge by 4 by 3 pi capital R cube. That is Q into R cube by capital R cube. This is enclosed charge for the point inside. Hence, phi is equal to enclosed charge by epsilon 0, that is Q into R cube by epsilon 0 capital R cube. Or E into 4 pi r square is equal to Q into R cube by epsilon 0 R cube. Or electric field E is equal to Q into R by 4 pi epsilon 0 R cube along the radius vector. it will observe that for a point inside, electric field is proportional to distance of the point from the center. Since Q and R are fixed for any inside point, for R less than equal to capital R. When distance is equal to radius or less than radius, then total charge and R are constant. It is obtained like electric field along y-axis and distance of the point from center along x-axis till the radius is distance is equal to radius. Then the variation of field is directly proportional to the distance, and beyond which the variation field is inverse square. This is a case of uniformly charged sphere. But in case of charged shell, spherical shell, the electric field was inside was 0. Electric field inside of the cell was 0, and on the surface it was certain value, beyond which it is like this, inverse square law. So for this point electric field is 0, and here R is the distance along x-axis. Another is electric field on the axis of a uniformly charged ring. Suppose this is a ring shaped conductor. O is the center. This is axial line. Let small a the radius of the ring. It is charged as positive or negative. Suppose it is positive, and total charge is Q. Let us consider a point, a distance x from the center on the axial line. That means if the ring is in yz plane, then we want to find the field in the along x-axis. If the ring is in yz plane, then electric field is to be calculated along x-axis. Here we have taken positive x-axis. This ring can be divided into small elements. Let delta Q be the charge of this element. Now for this point, at this distance, at the point P, electric field due to positive charge will be away. Suppose delta E1. And due to the diametrically opposite element, let delta E2 by the electric field at that point. The distance of the point will be s square plus x square square root. If delta L is the element considered on diametrical opposite side, let delta E1 and delta E2, the electric field at P due to elements delta L each on diametrically opposite on the ring. If lambda, the linear charge density, if lambda, the linear charge density then lambda is equal to total charge by 2 pi a. Let this be theta, angle theta. Now delta E2 or delta E1 is equal to 1 by 4 pi epsilon 0 delta Q by distance square, s square, x square, and direction of the field is as shown in the figure. Similarly, delta E2 is also 1 by 4 pi epsilon 0 delta Q by s square plus x square. It is observed that delta E1 and delta E2 are same in magnitude. Delta E1 and delta E2 are same in magnitude. Here, the two vectors delta E1 and delta E2 can be resolved to their rectangular components. So for delta E2, this is theta, this is also theta, this is theta. So for this delta E2, this is delta E2 cos theta, and this is delta E2 sin theta. And for delta E1 also, this is delta E1 sin theta and delta E1 cos theta. Now, delta E1 and delta E2 are resolved to the rectangular components, resolved to they are rectangular components. It is observed that delta E1 sin theta and delta E2 sin theta for any two diametrically opposite elements, are cancelled, and only contribution is along the positive x-axis as in this figure, or only contribution is along positive x-axis for this positive charge. If it were negative, then it would have been along negative x-axis. Hence, electric field E is equal to sigma delta E1 or E2. This is 1 by 4 pi epsilon 0 s square plus cos x square sigma delta q cos theta, since it is due to x components. Hence, we will take the addition of only x component delta E cos theta. So, this is 1 by 4 pi epsilon 0 s square plus x square into q, and cos theta is x by s square plus x square to the power half, or E is equal to qx by 4 pi epsilon 0 s square plus x square to the power 3 by 2, and it is for positive charge along positive x-axis, and for negative charge it is negative x-axis. Suppose it was negatively charged, then it would have been along negative x-axis. For positive charge, E is along positive x-axis, that is I cap, or for negative charge, E is along negative x-axis means minus I cap. Case 1. If x is 0, that means the point is a center. If the point is moved to the center of the ring, if x is 0, then electric field is 0. Thus, there is no field at the center of the ring. Case 2. If x is much greater than a, suppose this is x is more and a is negligible in comparison to, distance is more in comparison to a, then here a A can be neglected. That is E is equal to Qx by 4 pi epsilon 0 xs cube. If A is neglected, then x squared is xs cube, or q by 4 pi epsilon 0 x square. So here you can say if radius is small, then it will behave as a point charge. That means you can say that if radius of the ring is very very small, then it would behave as a point charge. Behave as a point charge.